Alright, let's talk about bond dissociation energy. So bonds between atoms have different strengths. For example, the CC bond, it takes 348 kilojoules to break a mole of CC bonds, but the CH bond takes 413 kilojoules per mole to break. So this bond is stronger. These values are just averages. Okay? They've taken values from different molecules, and I'll give you an example here over here. So the C in CCl4, which is Cl, 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 this bond strength will be different than CHHHCl. Right? The electrons will be distributed differently here than here, so that it will be slightly different. I don't think the changes will be massively different, but they might be different in a little bit, so we're looking at average values here. We call them bond energies, or we call them bond dissociation energies. Now, to break a bond, we need to add energy, and when bonds form, we release energy. Now, if I'm talking about a CC bond, or let's talk about the CCl bond, if to break it I have to put energy in, it's going to be a positive value, and when a CCl bond forms, energy is going to be released, so it's a negative value at that point. Now we can use these values to find the delta H for a reaction, and the formula we're going to use is this one. I sum up, like in math, I sum up all the bonds that are broken, the energies from the bonds that are broken, and then I subtract the sum of the bonds formed. So here's an example. Given a reaction, the first thing I need to ask myself is the reaction balanced? In this case, it is already balanced. If not, I might have to put some numbers in here. Next step is draw. I want you to draw the molecules out just like this, so I can very visually see what type of bonds I'm dealing with. So in this case, I've got, looking at this molecule right here, I've got CC bonds, I've got CH bonds, I've got a CO bond, I've got an OH bond, and then here I've got a HCl bond. How many CC bonds are there? There's 1, 2, so there's 2 of these, and it's 348 is the value when I look on the table of values, and you can find a table in your textbook, you can find tables online. When I look for the CH bond, it's 413. How many are there? 1, 2, 3, 4, 5, 6, 7. 7 of those. CO, there's 1, and that value is 358. OH, there's 1, and that value is 463, and the HCl is 431. And I get a total here of 4839 kilojoules. Bonds formed, I'm going to get, I see CCs, I see CHs, I see a CCl, and I see OH over here. I need 2 at 348, I need 7 at 413, I need 1 at 328. Again, these values you can find in your textbook or online. And there's 2 OHs, 1, 2, there's 2 at 463. And I total those, and I get 4841 kilojoules. And so now delta H is going to be equal to the sum of broken minus the sum formed. So in this case, it's 4839 minus 4841, and I get an answer of minus 2 kilojoules per mole. So when this reaction occurs, if I have a mole of this and a mole of that reacting to give me a mole and a mole, I'm going to get 2 kilojoules of energy released, which is a fairly small amount, but that's what this tells me. So here's another way to find the delta H for a reaction by using bond energies or bond